Here the maintaining supercritical flow very difficult. So there should be have one energy dissipator at the downstream side. So the main problem in this kind of the spillways, scoring problems. Score and downstream trajectory spillway, or you can say in USA they called here flip bucket. In Europe again, schism bucket they will call. In India also schism or trajectory bucket we call. Okay, here you can see next slide please. So this one my second job. So here you can see now. So what is happening here? See, so you can see upstream view. This is a model and prototype conformity. Perhaps this dam completed around 2013, I think, 2013 or 2013. Some floods happening. You can see upstream. The time, my giant director, Rajinikanth M. Katsurya Sahib, he wrote spillways books and hydraulics of spillways book. You can all refer his book. It's a very good book. He was, so that time only when project authority visited, that time he mentioned the upstream. You can see near this girder here. There will be problem. So same thing happened. So not the jet. So here also the time due to high velocity jets. So the right banks having so much problem. So you can see downstream we have provided one deflector, and also curtailment of right hand, flow right hand side deflector and left hand side some curtailment. So flow can be easily like a spray. Okay, so this is the problem here. Okay, next slide please. Okay, so I also associated with Iran Water Resource Agency. Iran, you can see this is the one of the their models. All you can either you constructed with cement mortar models or physical models. Another one in the with the glass. See perfect sheets. They have conducted several studies, and I have worked with them. And it's, especially you can see computation fluid dynamics. Many of other students they have done, but physical model give very clear and picture. Okay, uh, okay, okay. So here, next slide please. Okay, no problem, next slide please. Yes, spillway means spillway. In just now we use one is non-overflow section, another one spillway means you need to pass the flood water in excess of reservoir capacity to dispose floodwater in excess capacity safely. So you have to control through gate operations, and also you need to provide energy dissipator downstream side. Okay, so here just now as I told, a schism bucket or trajectory bucket or flip bucket. Different countries have different, but concept and purpose is same. Okay, next slide please. Okay, here you can see left hand side reservoir level and crest level spillway. So this figure I have taken from Damle in 1966, who worked great work in Central Water and Power Research Station, Khadakwasla. Okay, you can see the bucket radius R and lip angle phi. So we are all aware this jet should be very far. So schism jets throws jet away from lip, from lip depending on velocity and bucket lip. You all aware, in high school means intermediate or plus two level you saw if maximum range, if sine 45 degrees means x, the maximum range x equal to u square sine 2 theta by g. You all aware, right? So if theta, so this theta are phi, if 45 degrees, that jet will go very far. Okay, this is the problem. So here you can see H1 is head the reservoir level to tile water level. TWL means tile water level, and also ground level here. So you can see depth of tile water level, DW, and depth of score. So how much depth of score? This is the problem. This score takes place due to high velocity jets. High velocity. You can see turbulent flow, high turbulent flow. Is scoring. Even the big. So another difficult problem is whenever you conduct model studies, I will show show. We'll take sand, fine sand, D50 to mm, but it's showing pattern only. But this one model and prototype conformity, again, big challenge for hydraulic engineers. To prevent this uncontrolled score of riverbed and banks, what we have only two options. Okay, please click pre-excavated plunge pool. Either, you know another thing, rising tile water level by constructing weir sufficiently downstream. Okay, so two alternates. And also you can see LS is location of score. This is another very important. What will happen here? What will happen? Kawakami in 1983, it's a Japanese hydraulic engineer. They also done some research. Due to air resistance, we think theoretically, that's what the theoretical jet very high. Just now, as I told, you can refer several Indian standards also. We think no, it will go very far, but due to air resistance, jet come again near to main structure of dam. This is the another problem. It's called location of scout. Okay, next slide, please. Okay, here estimation of score can be classified under four different groups. Okay, theoretical analysis coupled with the laboratory investigation, theoretical analysis coupled with prototype observations, empirical relationships based on prototype observations, and lab experiments. Okay, in lab, it will give only pattern and phenomena, but as I believe, it will go and hit. Somewhere that's what you can see easily. That's exactly it will happen in prototype also. That's what I shown model and prototype. Okay, that's no problem. Only problem is scoring, scoring depth and pattern. Okay, next please. Here you can see this one, Subhansiri Dam Spillway, I think that one I forgot name. So factors consider to predict depth of score and pattern of score whole. Okay, number one, discharge intensity. You all aware means discharge intensity means per unit width or specific discharge also we can say means per unit, and also head. As I mentioned, Damle he considered head reservoir level -2, he consider until lip. But in case of H1 means reservoir level to tile water level. That's what I consider here, and also tile water depth, and also lip angle of the bucket, radius of the bucket, and particle size, D50, this one. Another thing, in this one I have not considered, to be frank, rock quality designation, especially prototype observations, rock quality designation, rock mass rating. Okay, several investigators developed almost, see this one a very old topic, 80 years old. So first time awareness and Damle, so all they consider only discharge intensity and head. In my research, I have considered all other parameters. Why? You can see rate of change of momentum equal to force. See how much radius and your lip angle. So that is main cause. So that's why I have considered here this one. Okay. Next slide, please. You can see this one upstream view. I can actually video clips. I don't know why. See failure of formula. See Bureau of Indian Standard and USBR small dams. Both they are still considering awareness formula. You can see bottom 1.9 q rise to this one power of 0.54 and head 0.225. In case of Ukai Dam, you all aware, recently they inaugurated. I forgot to share Dr. Mehta to this video clip. Okay, I will share. Okay, you can see. So in case of Ukai Dam, the observed score was 27 point, where prediction 18 meter only. So it's what happened? Under prediction, right? 27.4 is very high. So they predicted. In case of Rana Pratap Sagar, same, no, 18-meter gave, but observed score is much more high. In case of Kariba Dam, where this one, in Zimbabwe, African dam, each year and each 10 years, you can see the formula gave 42 meter, but real observed score was 70 meter that time. So almost double. You can imagine this all dam height 120-meter, Kariba Dam, but your score depth like this 70. So almost two-thirds. So what will happen? You can see it's very similarly in South Andhra Pradesh, Srisalam Dam. What they made blunder mistake, the lip angle of the bucket. They put 30 degrees, so that's not going further. So it's like due to turbulence, the score takes place. Okay. Another thing, due to this complex, many even never takes so many equations. No one solved this one, this problem. Okay, so this one problem is remains inconclusive. This one all empirical formulas. That's why I told four categories. So then I have used neural networks for this one. That time, if problem is poorly defined, neuron means nothing. This one information processing element. See, the way I communicated just now with your coordinator and all the promptly. Sometimes I means I'm aware, but I don't get time to reply. Okay, so this all means how the same way how we will think, how human brain, so neural networks also behave like that and work like that. Okay, next slide please. Okay, so this is the some old literature. Earlier days, in electronics, electrical people, since voltage up down, so they used it first time. So very similarly, in 1991, 92, Trent and the civil engineering applications came. Then many in hydrology they came. Means rainfall, runoff modeling. We are giving rainfall, but we are getting like simply like black box. You are getting runoff. You will say your teacher say R equal to A plus BP. So what are those constants? So this Karnaniti, this meaning go in geotechnical engineering, Tirmalaya and Dev, Professor Dev, who was my supervisor, and Liriano and Day from UK, they have done for this peer score. Okay, and Negi et al. They have done in sediment, sediment concentration, suspended load. Okay, suspended load. They predicted. That's why these papers are very good papers. So you can refer. Okay, next slide, please. So yeah, here you can see in neural networks there is an input layer, first layer, then hidden layer, then output layer. Here you can see bias. This one very similar, like your dendrites, okay, synapse. This how our nerve cells working, neuron information passing on it. Input. Okay, here what will happen? Input multiplied by weight plus bias. Here you must normalize data like whenever you go school, so you have to all have uniform, otherwise what will happen? So if any monthly rejection came, then we will give priority, right? So there is no otherwise bias, right? Bias. Suppose I know now, just now in the heart. So next time we called, I will bias. So that should not be happening here. So that time I used a neural network simulator from Stuttgart University. Now the many like Excel, you just like one right click, then you will get. Here problem is how you will select in data, how you will normalize data, and also any noisy data, and how much data are required. That time I will show you only 75 patterns, 92. Then I used 75% training and testing. Okay, here input plus multiplied by weight plus bias through transfer function, then you will get output. Then here you can see error is propagation, so you will get, you need 100% results. Okay, this one another time, this one called supervised, means you are giving output. Supervised learning means your teacher there, like you give some target. Okay, this one called simply feed forward back propagation. Okay, but error is propagated. This is a slow algorithm, but still give good results. Okay, next please. Yeah, another one, Cascade Catalyst. Here, what will happen? Hidden nodes keep on adding until you get good results. Okay, your mean square error, root mean square, average error, many error there. Okay, this one Cascade Catalyst algorithm. This all available in MATLAB code. Okay, next please. Okay, another one, this one, same like RBF, radial basis functions, same like centering. It's all in, I used it in MATLAB, so that it automatically it will transfer. Normally, many other softwares they will do normalization between 0 to 1. Means whatever big value, it will become 0 to 1. I will some of my papers you can refer how to normalize data. Okay, then but in MATLAB you can see this one, only in MATLAB they normalize data from -1 to +1. Means the function, you saw normalized curve, right? You all aware in statistics. So it will give exact value. Okay, next please. Everywhere same input layer, hidden layer. This one, another one, ANSYS. Nothing but how your washing machines work. Okay, if then else. If then else means here neural networks plus fuzzy logic. Fuzzy logic means how your washing machine works. What they gave in MATLAB. So if you go for any restaurant, he will serve food. Means his hospitality, his food good, his the infrastructure good, everything good. Then you will give tip. Okay, if no, nothing. So here it will develop all membership functions. Okay, so what drawbacks here? Only giving some weight matrix and bias, some rules. It never appreciated by any practice engineering. That's why in recent years, I and Aytak Guven, another Turkish professor, we have used gene expression programming, which give very similar to your regression equation. Okay, your regression developed equation, it will give exactly. So recently, almost now many softwares can many advanced trees algorithms, genetic algorithms, and then gene expression programming came. Okay, in there are many other types came. Support vector machines came. Okay, okay, next please. Okay, these are the large number of equations there to develop ultimate score depth. Then many equations simply the ignoring effect of some impact factor, like just now as I told. Then in Damle, Virnas, they did only two variables, input variables. They never consider, right? Suppose who is operating this one, Rohit, right? In Rohit, in inside water. So if Siddharth hit something, it won't affect, right? Means already in tile water depth. That's what, if you maintain some tile water depth, that's what, if you sufficiently rising the water level downstream side, so whatever jet came, so that is the, nowadays they are making plunge pool, means pre-formed plunge pool. Okay, another thing, this bucket radius, very very important, but they have never considered till now. I don't know why. Then I published this paper in AC Hydraulic Engineering in 2004. It appears in 2005 October. Okay. Then also again one more paper I published in International Journal of this one what Journal of Hydraulic Research. So, okay. So this one less attention paid by geometry. Another thing I must inform you, that time they have given only depth of score. No one bother about width and location. So which give this one or plunge pool dimensions. Okay, this is the okay. Okay, and also material properties also they have not informed anything. They just consider only head and discharge, means specific discharge intensity two. Then they told this much score depth will come, but still it will work, Damle's formula. Okay, but he considered the main difference between me and his one, the head difference I considered until tile water level. Okay, head reservoir level to tile water level. Okay, next slide please. Okay, another thing, see, I also collected all data, prototype data. Okay, then at that time neural networks have many advantages, over the statistical model, means regression equations. Is model free. It really it will works. When I developed the model in MATLAB, it works continuously. It gives code depth, length, and width. Okay, only width due to lateral energy dissipation, less prediction. I faced a problem with width of this core hole. Okay, other thing all very nicely gave. Okay. So the main criteria, whenever your problem is poorly understood, you can go for this kind of techniques. Now you all aware, right? Even in share markets, electrical engineering, many even concrete, environmental engineering, everywhere they used all. But in this one, what we say outdated, but still it's okay comparison to other problems. Once you knowledge extraction of knowledge using this trained model, that also I published it. And so how I will show you in later slides, extraction of knowledge with trained model. Okay, next slide please. Okay, these are the some objectives. Means I conducted a fresh flume studies. As you know, here you can see prediction of depth, width, length, means the geometry of this core holes. Okay, next slide please. Yes, that time some comparison I made. Okay, with traditional formulas. Okay, also linking of functions with underlying physical process, carrying out parametric studies and sensitivity analysis and perturbation. What means, if you have noisy data, suppose say your input is negative 10%, minus 20%, or positive, means then what will happen to your output? Okay, that also I have studied. Okay, another thing, this one consider as a black box type, how it will work. Then again, extraction of knowledge with the trained neural network model I have done that time. Okay, next please. Yes, here you can see data related to I have collected and I have conducted also here. So okay, discharge intensity, head, tile water depth, okay, lip angle of the bucket, radius of the bucket, and particle size. Here the outputs are score depth, score width, and location from lip. Okay, so training sets I have taken 75 and testing 20. Okay, here you can see this is the Parbati Dam spillway. You can see a picture. It's very similar. See, so here three spans. This one 1850, I think, discharge meter cube per second. Three. You can see the jet how it's coming. You can see also rooster tile. And this yellow two piers there. So whatever coming, that's what problem happened here during the time? Next slide, please. During model studies. Yes, here you can see this one. So you can see here erodible bed material downstream side. Okay, this fillway you can see with three spans with two piers. Okay, okay. What will happen here? You can see the jet was hitting to this right bank. Okay, jet was hitting to this right bank. Then what will happen? So the only option, you cannot change anything. Okay, we are humans, right? We cannot change anything. So what the idea that time, only dam axis. Okay, this one nature, right? In nature you are building dam. So this is the proposed design. So how we will change? So the same way like Doliganga, the jet is going and hitting this right bank. So what is the solution that time? The only idea, the dam axis is a little bit tilt. Okay, then okay, next slide please. You can see here this one upstream view. You can see power intake also. See exactly how prototype, exactly this one is to 50 scale model, diametrically similar model. Okay, you can see three upstreams. Okay, the breast walls also you can see three spans, and also piers you can see two middle and half of near apartments. Okay, next. Okay, next slide please. Okay, so whenever you want to, you want to generate power, so power equal to gamma QH means your head should be very high, power intake. So that's why this all you can see, this all national NHPC projects. Okay, so you can see this the left hand side before running the model, then right hand side after you are running the model for different discharges, means 50% discharge, 75. The total discharge was 1850, I do remember. So you can see the maximum score, means you can see contours, how much distance it came. Okay, in model itself more than okay, um, okay, nearly I think I forgot more than 1.5 meter I think. Okay, more than that. score takes place. Okay, jet hitting. Okay, next slide, please. Yeah, here you can see clearly on the jet is hitting to right bank. So only option, you can change your dam axis. Okay, with the idea. That's why physical modeling is very beautiful, and you must know. The only thing is laborious, and you have to have very patience. Okay, you all aware, right? That time, no one was listening to me that time. When I came from Delhi, they thought, in India, same, that's very, like where near Simagad people, my with me, they're working. They're very seniors and more than much age. Then they say, what they say, kal laga hai tum kaam pe. I don't know Marathi that time. It was then very challenging. Okay. Uh, Finally, 3 4 models I have completed with them. Okay, very friendly. Okay, you have to have very patient. Sometime I don't have any office that time. Trust me. Now maybe many offices, so we have to everything work here only. Sharing tables and drawings. Okay, you all aware, right? You have been, I think, Kadakwasla, which is biggest laboratory in Asia. Okay, next slide, please. Okay, in model itself, see here, you can also see how flow, they will also test the training walls. You can see water profiles all. So this all again need to plot and preparing reports, very challenging, and also patience. Okay. Mm. Then you can also see rooster tile means near peer. So that also, this much energy, this all ski jump, this much coming. So this will hit. Okay. And also your reservoir level is full reservoir level. Okay, full reservoir level. Okay, so since you want to generate power equal to gamma qh by 75. Okay, head should be so full reservoir level. This one I think 2192 something, I forgot the values. Okay, elevation, this all in Himachal Pradesh. This one Parvati Dam Spillway. Okay, 1:50 scale model. Okay, this I have done. Okay, next please. Okay, so you all aware in second year, you have studied, dimension analysis and Buckingham Pi theorem. Okay, Rayleigh's method, anything. So here, depth of score is a function of, I say, discharge intensity, head, bucket radius, bucket radius, and lip angle, rate of change of momentum equal to force. So how much this is a very important factor, and also tile water depth, DW, and the D50 bed material size is very important, which Damles are and not considered that time, and also density of water and density of sediment. In our case, no, we are civil engineering, we are dealing with, with only water only, and also the sand. So you can, okay. Then similarly, location of score, LS, and width of score. Okay. Next, please. Then I got this after using Buckingham by theorem. You can use, very simple method. You can take as a repeating variables, and you will get 1 2 3 this one. Okay, this one fall fraud number you can call first one, or simply densitometric number you can call. Okay, they change, somewhat. I just say fraud number. Okay, I did not in next papers. It's a ds by h means depth of score versus your head. Okay, ds by h. Okay, so you can change, you can play that, then you will get a fall fraud number. Okay, this one just a fraud number only. Okay, then relative head, you can see bucket with respect to bucket radius on this one. Okay, these are the your five groups. 5 1 6, correct. So one you can remove, since the density of sediment over density of water which is constant, so no use. Especially another thing, in neural networks, if same like if you consider g means gravity 9.81, then you will never get results, means your inputs are very same. Okay, that's why. So what finally I must define neural network is, it's a technique, mapping of random input to random output. Okay, this it's called neural network. Okay, so now here depth of score, width of score, and everything with relatively with respect to your tile water depth DW. Okay, next please. Okay, so with the statistical regression, you all aware least square fitting. Okay, nowadays software there can all we can see here left hand side. This is the first equation. Mm, okay, you can see fraud number how much 0.694. Then head. See, these are the two very important. You can also see the with the bucket radius is going inverse relationship. You can also, but you can see with bed material it's showing correct and lip angle. Okay, 0.19. So in case of location, see you all aware, right? What we aware with in high schools we studied, right? If in Diwali your rocket how it go, or anyone you all studied, right? If 45 degrees it will the trajectory will go very fast, like missiles and all we studied in physics, high school physics. Okay, here you can see very high it can see 5. Hmm? Power 0.34, that's what you need to observe. And also you can radius also see positive km, and head also correct. Hmm? Head also very important, much more km, and 0.42 with the fraud number. Okay, then next here width of score, next equation please. Yeah, here you can see something, you can see something, some some funny, with the fraud number it's showing negative. So my supervisor, normally if you show anything wrong, they will ask right easily why negative. Run in front of me. Okay, many doubts. Your teachers will get many doubts, right? But you can see width and head is very good, 0.55 km, and even bucket radius came, and especially D50 also came good. Okay, so this one least square feet approach, you can easily you can see any. At that time we used to write C language or something. One book there, C language. What is name? I forgot. Some Tamilian name. Okay. Uh, so that time now nowadays very easy, even you can with using MATLAB or anything. Okay. Even sometimes Fortran also they will write some programs. Okay. So okay. Next please. I will explain this performance of these equations. Okay. So any equations, if you develop any model, you need to, even many hydrology also, correlation coefficient. Perhaps you have all studied in hydrology also. Otherwise, you also studied in numerical methods in any civil engineering. Maybe you have my time numerical methods with some Fortran language, my time. Okay. 1990s. Okay. From Andhra Pradesh. Okay, another thing. So any model. So suppose the Rohit good all subjects, but what grades he got? So nowadays everything grading. Correct, especially uh, semester time. It's very difficult. Our time really yearly pattern, and we study your education nowadays. Even here, University of West Indies here, only 3 years. Another headache. All my students like fast foods. You are going KFC and buying like degree. Like it's a very stressful. Another thing, all all world this accreditation drama came, really, to do research, no time, only accreditation, nothing else we are doing, to be frank with you. Okay. No other time, only accreditation. I don't know, now we have not America one, London, British people. Okay, still same thing going on here also. Okay, so any model, anything means any. So here, so correlation coefficient, which is very sensitive, mm, very sensitive. So that's why if you submit any papers to American Society of Civil Engineering, they prefer mostly in American researchers root mean square error or simply mean square error. Okay, next please. Okay, this one any average error. Another thing, if you positive or negative, another headache, so you can put one more modulus, means average absolute deviation. Okay, these four error measures I used to whether your model is generalized good or no, how you will say your model, since you have cascade correlation, you have backpropagation algorithm, you have ANFIS. So you have many things, but Rohit may be good in fluid mechanics, maybe his structure also good. To be frank, me, I was very good good in structures, 100 out of 100. Our time, our professor CS Reddy, and even hydrology, I study from Professor Jairam Reddy. Perhaps you all aware, our times. Though, Professor Narlikal failed me in master's level, he asked, his warden, he will ask, where he went yesterday. Then if you say that time, in a movie, then they will fail very strict, especially autonomous college. He will correct your exam paper, even IITs also, your paper in front of him. That one another stressful. Okay, so I study twice hydrology during my master. Okay, come back to here. So which model is good? So these are the four error measures. You can decide which one is good. Okay, next please. Okay, here you can see this one. I'm talking about only this three equations developed, means simple least square, means you can say regression equations. Okay, can simply, so you can see correlation coefficient in case of 0.84, and location of score, it's giving very good, see 0.93, and width of score again 0.88, means here. So another thing, this one correlation coefficient. That's why people, what many researchers, what they coefficient of determination R square. Okay, which is near, means if they say if more than 0.5 to, but where our professors and journals never agree, unless otherwise you will get good results. Okay, otherwise you will never get degree, or they never allow your even final year project. And all. Here with my students also, my student PhD Prashant also, here you can ask him how journals and reviewers, even me, how they, so in case of average error, you can see negative came, and all, see sometimes means over prediction, under prediction. Okay. Hmm? Okay, mean absolute error, mean absolute deviation, root mean square error, you can see this one. This is about model data. Okay, next please. Okay, you can see anything only telling with the models. So you must have scatter plot. You can see two outliers here. One is under prediction, means this is the degree of best fit, means a perfect line. Okay. 45 degrees line, this one. Okay, this one in x-axis observed score depth, then y-axis predicted. Okay, observed was, so your correlation coefficient 0.84. Okay, if you, it means r square, how much it will come, maybe zero point 0.7 or something, right? 88 so okay. So you must have to go for either neural networks or fuzzy logic one, ANFIS or gene expression programming. Since this one regression equation giving again, you can see. Okay, this is the data. Okay, in case of observed score depth. Okay, next please. Okay, and in case of uh, width, you can see mostly all, under prediction. You can see with the range 0 to 20 or 17. So most of the points. Okay, it's called outliers also sometime, right? Then you have to remove. Nowadays there is how to remove, they are using a spaces software and all. But once you should plot this scatter plot, you easily understand. Okay, okay, next please. In case of the location of score, again same, means if high value, means how, another thing, this one all testing plots, I'm not plotting training one. Okay, so so testing means which you have not used during training, means I will ask, I will give training to Rohit bus, but I will ask Rohit to drive car. Okay, so means range only. I cannot ask Rohit to drive airplane, right? Or any train. Okay, so this is the another limitation. Means within range. Means my Parvati Dam spillway or even Doliganga, how much head there maximum, how much maximum discharge. So within range only it will work, right? That one true, correct. Not this one. That's what. So another limitation, right? It won't work beyond. Okay, so training and testing, sometime validation. In MATLAB, if you go, they will say 50% training, 25% testing, another 25% validation. Okay, if you go, and also data also, you need to see minimum to maximum, and in between only, see, that's what. Okay, next please. Okay, so here, see, so this is the beautiful dam, Salal Dam Spillway in Jammu Kashmir. Okay, after seeing only all, you should, I motivate my students. See, how nature, how beautiful. So, right. We cannot live without nature, but nature can live without. But so many environment activists again they angry, right? You know all the stories during construction of Sardar Sarao or anything. Okay, when I don't want to take names. Okay, but we must need, right, this kind of dams. Why we need to, many purposes, right, for irrigation, drinking, storage. See, you can see storage of reservoir. You can see, and also power generation. Correct, we need. We don't have anything like other oil or anything to generate power. So we have only source. Okay, same thing. Okay, another thing, Rabi, Kharif, rainy time, rainy season time, you have to store water, and sometimes dry season you need to use. So this is the Sardar water Salal Dam spillway in Jammu and Kashmir. Okay, I'm not talking about Sardar Sarovar. Why means problem, and they will need, we must, we build the world. Okay, okay. Next, you can see here, also downstream side. What you are observing, white water. You can see, please, white water. What happened then the time, I don't know, 1998 or some time, not 98, 88 or sometime during that period, they inaugurated. What will happen? You can see. So the discharge 150,000 cubic feet. Okay, next slide, please. So, okay, ski jump operation during. See, all water color also everything changed. You can see what happened to right hand side. Some power generation. This powerhouse, everything gone. Nothing there. Next slide, please. See here. So this much 1,50,000, right? 150K. You can say cubic feet. Okay, not meter cubed per second. So so you can see color of the water, please. Now, what color you can see, Rohit? You can see sediment, everything. See, color, everything changed, not white water. Correct. Okay. So something happened here, means cover takes place. How much gone, God knows. Okay. So nowadays advanced technology came, they can measure. Okay. So you can also see here rooster tile. Okay, I immediately see during this shoots will way. Okay. So this much happen. Okay. See, even fog more than height, you can see here, more than dam height. So this thing happened that time. Maybe I don't know. Then the time prime minister what action taken against engineers. Okay, my boss was telling this one all. Devlalikar Sahib was telling the stories. So I, luckily I got those photos. Okay, next please. Okay, you can see now clearly. See what color, Rohit? Downstream side, everything means all matti matti. What is it? Mitti ka mitti. Okay, all red color. Okay, see. So imagine what was wrong. Okay, it means pre-formed plunge pool not there. Okay, okay. Next slide, please. See, this is the my state from. I belong to Andhra Pradesh. Okay, this one where I studied engineering. Okay, this one Three Salem Dam Spillway. So here, every year they will afraid whenever flood came. Flood nothing but unusual stage in river. That's what defined by your Subramanya textbook. So, okay, so this much. So how score and all the what mistake they made here now, again. So that's why if they have see lip angle very far, but what my boss was telling that time, if 35 degrees to some even 45, how it will works. But all model studies 1 is to 42, 1 is to 70, which gives good results. That's what they proved, even European hydraulicians. Okay, so here problem is 30 degrees, so your jet is coming very near to structure, see main structure lip, then immediately not going further, even though so much energy there. Energy means, okay, you all aware, right? Energy equation, velocity head, pressure head. Okay, um, okay, next please. Okay, then I also developed, as this Damle Farla, when I saw then many publications, they provided discharge intensity and head. So I try to plot. You see, there is no sense. You see, there is no relationship. See, highly scatter and see, very random. See, discharge intensity. I try to plot. Okay, so same. So okay, two parameters universally they used. Okay, with this one all prototype data. Okay, all 93 dams I have collected, published one, but I did not go personally to collect data. Okay, next means actual field measurements, no. Okay, another thing, score depth versus head. You can see how much. Mhm. Okay, there is no relationship. So such a time now you got a good example. If there is no relationship, then you can go for this neural networks model. So I try to develop with the two input model. Okay, next please. I will show repeatingly coming. Okay, next please. Yes, this one please. Thank you very much. So here you can see only two inputs in input layer. Okay, same way I divided data, but I consider 70% data and 30% for testing. Okay, training. You can see q. Mm. And two input neurons, input nodes. If the node or neuron same, neuron means information processing element. Then this one weights and bias say theta 3. Okay, like same thing. Then weights and bias. Okay, it's simple. Okay, one output only depth of score. I did not do anything. So this work I published in hydraulic research. Okay, next please. Yes. See, this one similar feed forward graph question algorithm, feed forward cascade correlation, and rail basis function, and ANFIS. Now, many came now in advance, especially if you use MATLAB, they will use LM. Students are very fascinating. It will come very fast, but it will stuck up in global minima during training. Training was just processing. Okay, nothing. EPO also they will say some EPOs, but especially professional, it will take time, but it will give good results. Means you can capture that weight and metrics, then you can predict again for testing time. Okay, comparison of observed this one with the neural network model prediction. Okay, you can see here, you can see still some outliers. Okay, which one give FFBP at least, and though some over, some under, but it's near your perfect line, means best fit line. Okay, next please. Many outliers you can see here with RBF. Okay, I mean the underlying and all. Okay. These are the traditional researchers, Martins, Veronese, and all. Their correlation coefficient you can see, observe how much mostly. See this plus one whose Veronese formula completely failed, either under or over prediction. Okay, then only then in its formula, at least then awareness formula, though you can see. That's what another thing you must observe here. Though here very good correlation coefficient, but still either outline. That's why it will give mislead, it will. That's why always our professors also say, even though if you plot, if you give results, you can try many times, even correlation coefficient getting good, but if you plot, you will get funny, then you will think, I made a mistake or what. Okay, several times you can double check, huh? Okay, nowadays all we are all, no mobiles, means mind concentration another thing. Okay, yes, next please. So this equation I developed with my one, though you can see here. No, it give no, like same like previous equation, but you can see here 1.42 q raised to his equation 0.42 came, my 1.44, small difference. And then h also same, his 1.22 something came, my 1.3. Okay, that's the score. Okay, this is the scatter plot. Again you can see some, you will get normally. So if I plot exactly same perfect, then my supervisor, even if I submit a journal, they will catch on something wrong. But we need to be frankness, and we should not anything cheating or something, right? Whatever came we show, that's all. It's up to them. whether accept or no. But this much only I got. Okay, this one reality. What I am trying to say, there is a still outlier. Okay, next please. That's why it means with regression. Okay, then you can see here average error negative came, then within cascade correlation negative came. Okay, RBF you can see from author, but you can see ANFIS. ANFIS means I told just now neural networks plus fuzzy logic. It give highest correlation coefficient 0.95. You can see, please see. Mhm. I should use this. Okay, so 0.95 this one. So this is the best one. Okay, you can also see my equation 0.77, which is little higher than the existing researcher, means traditional researchers. That's what I done. Okay, next please. Okay, next please. This one for model. Yes, now you can see here. So you all remember, right? Dimension analysis. Okay, here you can see left hand side raw variables only. I did not do anything. Raw variables first time using raw variables and the actual inputs and outputs. Okay, left hand side you can see 1, 2, 3, 6 discharge intensity, head, bucket radius, bed material, depth of tile, water level, and 5. And output see continuously. You need to have, right, for plunge pool depth of score, location of score, width of score. Okay, then it works as a like continuous model. Okay, that's what the beauty of this model neural networks. Okay, next please. Okay, now you can see it reduced 5. Okay, fraud number first one. Okay, then second one had relative head, relative to bucket radius, bed material, and 5. 5 is very important, right? So what I am trying to say, the previous researcher they did not use. Then relatively, everything relatively correct. With respect to tile water level, right? If you maintain, then you can save your dam. It's all for safety of design, correct? Design of dams. So dimensionless parameters, and also even matrix size during matrix, right? It will form matrix. So your 100 by 100 matrix, you will get quick results. So we prefer and we recommend the second model. Okay, that time. So that time I developed ski score with MATLAB. That time I developed some coding, everything coding. Okay. Only thing is eyes will get strained. But what to do? And the networks need huge data. And also now, although we are not programmers, but we need to learn, right? Otherwise, civil engineering. Correct. You all aware, right? Canis method, another moment distribution method, even VPANET. How many softwares, right? Now, any project if you touch, my students also, they know many softwares. Okay, next please. Okay, so this is the, see, you can see here the post means the training. So backpropagation algorithm is taking this much time. Okay, this much CPU time, 900 seconds, means how many? Okay, then RBF very fast. You close eyes and open, that's much time. Okay, so this one, if you neural network works, if you type in coding in MATLAB, you can write TIC command. So number of training cycles it will show. Okay, so here you can see 6 inputs for all, but hidden neurons you can see cascade correlation. I told, right, one by one, it adding until you get good results. So you can set target. I need goal. I need zero error, but you never set zero error, means never come. A little bit some thing relaxed. You can 0.05 or something error you can put. Then it's very good. Okay, we cannot expect, right, 100%. Okay, okay. The RBF 19 hidden neurons. Okay, next please. Okay, for model 2 you can see. So time also 900 to 600 it change by matrix size, right? Then also RBFC just within 2 seconds. Okay, okay. So like this. Okay. Even hidden nodes also reduced, right? Since your model size very less, since your inputs 5 only, previously 6. Okay, 3 outputs. Okay, next please. Okay, the comparison. Okay, on scatter plot different. So here cascade correlation model showing very good. Okay, 0.977. all same. Even one decimal only that time. Another thing, even RBF model 1.984. Okay, that also good. But you can please observe how scatter plot showing. Okay, next please. Okay, RBF model 2, this one we recommended that time, I believe 0.989. Okay, same thing. This one for length. Okay, location of score, this one width of score. So the thing, these are the results the time. Since you need to show any scatter plot, you must show either uh, either, okay, scatter plot, but you must provide there only this correlation coefficient. Then any designer, any even your teacher or any reviewer, they can easily say, okay, this one. Even for yourself only, how you will judge, how you will decide which model is good. Okay, next please. Once you put on paper, once you put table, then it's the table. Now it will got so length table, not going through same results. Okay, next please. So model 2 only we recommended. Yes, this is the model 2 recommended one. Here what I did, I have saved the weight matrix and bias matrix. Okay, that's what I done. It's weights and bias with 10 hidden neurons. Okay, you can see bottom 5 inputs, 10 the nodes and 3 outputs. Means continuous model. Okay, next please. Okay, then what is the significance? Means how we will know. Correct. Today Rohit there, so he's helping me. I really appreciate him. Correct, for his patience. Since if I touch my laptop, this will automatically, my keyboard, it will go. That's why. Okay, here input parameters. These are the my input parameters. Okay, how it will happen? Okay, next table, please. So it's called some sensitivity analysis. First time I will take two, only two. You can see discharge intensity and head, only two first now. Okay, like Damle, other researchers. Then I added one by one D50. Then what will happen? Next, okay. Then finally, I see, like if I don't want to with my camera off. So if I want to lift this bottle with two fingers or five fingers, when you will easily lift, if all five, you easily lift. Same common sense, right? If all five variables, it will give good results. Okay, that's what. Meaning everyone know, but still for research purpose, you have to prove. Okay, the similar way. Okay, next please. Okay, here see how then I catch right hidden neurons with one by one. I have proved. You can see the same way the you saw right my regression equation. You can see, go back and check. So that time I totally become mad, but I proved. You can see the coefficients 32.27 and all. So that's why this paper got published there. So some laborious work there, some challenging job. Okay, from I was working in Pune and need to go Bombay, not easy, right? The daily customers, the train, I have to sit near toilets on ground floor. Okay, in trains. You all aware, right? Pune, Bombay, who travel, they never allow us anyone to sitting. Okay, another Indian culture, right? Once if you put any kerchief, handkerchief, that seat is yours. Okay, so like that I go on the study, okay, to Bombay. Okay, uh, so this is about depth of score. You can see, okay, this one the connections. Okay, so capturing really become mad, weight matrix. Okay, matrix size also you can see. Next please. Connection weights, and you can see for that one for raw data previous table, this one next one, you can see exactly it's matching with your regression equation. This is what I done. Means neural networks not black box model, I have proved that time. Means extraction of knowledge with trained model. Okay, clear. Okay, okay, next please. You have slides, you can go and you can shoot email later. Whenever I free, I will reply to you. Then parametric studies means how? Means first time, especially if you have physical model means you can play anything like okay. You can change. That's why I show Iranian hydraulic research laboratory. If you have lab, then you can play anything. Okay, keeping all input varies, but one as a constant at a time. Okay, then how it change. The next slide, please. Then I will easily explain. This is the parametric studies. You can see keeping one, then how it will varies. And this one common sense, right? If Rohit jump from high head to there, it will to tile water, it will happen. Means due to head. Okay, score depth also high due to energy, right? Common. Hmm? But here you can see depth of score and with only two things is uh, relatively means some is inversely proportional, some is relatively. You can see here. What is the green one is bucket radius means inversely. Okay. Then also phi same thing. Means if more lip angle, I told right, it will go further. And also your blue one bed material. See if bed material is very high, no score will take place, right? Means if you have big boulders. I can share next time to that paper, one of the paper with Professor Jarrett with USGS, for Colorado streams I done. You can refer that one also. You can see how much big boulders there in field. Correct. In model we say small sand, 2 mm, 4 mm we will use. Okay. Think next slide, please. See how it's varying means this one more, that one more. Then perturbation. Also, I told right, zero error of data, no problem. If your data is noisy, means negative and positive. Okay, so this is the how your correlation coefficient varies. So it's called perturbation analysis. Okay, with the observed score depth. Okay, next please. It's all I plotted all in Origin, Origin software. I like very much Origin. I don't know. I really don't know Excel. Not Excel using. I am very much afraid. Never use. My students were using. Okay, perturbation analysis. This one model one. Okay, with respect to score depth, score location, and score width. You can see now. You can easily see if -5, what will happen. Not much. 0.97. Same. Okay, another thing. In case of width, so completely decreasing. Okay, it change, right? So it should change. Otherwise, your professor will be angry. Something wrong. Okay, next, please. So model two. Yeah, okay. Then also ranges the hidden H1, H2, H3, and how it's working. This again matrix. Okay, next, please. Yes, here you can see correlation question between hidden neurons and okay each. So this much have done. Then okay, next please. Okay, then on this simple application and nothing but fuzzy logic and neural networks. Okay, so nothing. This will give only memberships. Memberships. If you give any designer, they will not happy. Correct. They need direct. Field engineers want directly. They want to use calculators nowadays. Okay, they will use many laptops and computers. Previously, only they want with how the simple calculators. Okay, now you can give complex equation, but they will not appreciate, no, if you give big equations. Okay, and means rules, fuzzy rules. Correct. If then else. As I told, if you go to cafeteria, any restaurant, how you will, if everything good, you will give good tip. Otherwise, nothing. Correct, like that. Fuzzy logic. This one, fuzzy logic. The simple membership functions by Jade. Okay, this Iranian guy who developed this one. Okay, many papers. Okay, next please. But it will give good results. See here, you can see fraud number, then relative head, bucket radius, and med material and phi. Okay, so here only two rules. You can see here I cannot use many. Means only depth means depth, not score length, not width of score. Means only one output. That is the main difference between networks and INFIS. Here only one time. Okay. Okay. So what is time now? 30. Okay. Okay. Next, please. Is time is over or no? How much time I really did not ask, madam? Hello, Rohit. How much time I have?
Sir, you can carry on till the
I
time.
can carry on, but sorry, I cannot. I cannot speak much loud. I must have inform right here night, right, 2 o'clock. Otherwise, neighbors will angry. Okay, I will talk slowly only. Okay. Okay. Yes, please. Here you can see input membership functions and rules, then output membership functions and output. Okay. But design, as I told, designers never happy, right? If you give so many rules. This one at least okay, only two rules. My another student one sediment when he worked he bring 50 rules, then I only become mad. Okay. So sometimes for research purpose it will papers will come, but in reality, if you go any NHPC design office, they never appreciate. That's what I want to say. Okay, next please. So means some drawbacks. Okay, thank you. Next please. Okay, here you can see at least okay, right? Only some under prediction with respect to observed versus predicted. Okay, data diagram. Okay, score depth. This NPC result. This one previously not compared. This one. Okay, next please. This one not included in my ASC paper. This one separately. And that paper accepted. Then I still was working that time. Okay, so this one. Okay. Location, of course, this is very important, which previous researchers not considered. Okay, so still some under prediction. Then
फ्लैट रेंट
also
पे देने का
with the
बोल
score,
रहे
with the score.
रेंट पे देने का बोल रहे
Okay, this is the scatter diagram again, observed versus predicted. Okay, next please. This all results like this only. Anything you can see. That's what I want to conclude. Before conclusion, I must tell even bridge pair score, abutment score, anything, even hydrology, training, testing. Same kind of results. Same. This four error measures just now I showed, right? Correlation coefficient of determination. Okay. Then average errors. Yes. Uh, Yes, what will happen? Deflector, other that will I will conclude. Okay, so now what I mentioned right earlier, only Q and H one they used. Okay. Next slide, please. Some comments coming means I will mention. Okay, so these are the thing, but I will share one more paper quickly to madam. Okay, she can show my gene expression abutment score paper. I will share to madam. Then madam will share to you. Give me only 1 minute. One more paper, then yeah, I share to Prashant, right? Yes, I will share to Madam Megha. Uh, okay, yeah, this one at least you can show this one, please. Please pass on to this one, Siddharth or Rohan. Mm, to Rohan. Okay,
No,
this
sir,
one
I'll.
show this one. Yeah. You can. I share that one. Okay. This one. Okay, this is the thing. Okay, what will happen? So this one extends data. That what is even the audience also the boring. Correct. So no equation, right? Till now where only other than regression equation, nothing we saw, right? Only like a black box. I'm giving hidden neurons, that is weight matrix. If you give weight matrix and bias, no one will appreciate, right? If you go design office NHPC, they will angry on you. They say, what is this? They don't understand, right? Okay. Can you share this one slide, please? Those one finish. Can you go end, please? Those
Yes,
presentation, please. No. Some plenty pull clips there or no? Two, three slides. Rohit, can you go end, please?
sir.
Yeah.
Sir, I'm
In the PowerPoint. Mm.
presenting your paper first. Okay, I'll
Okay.
first end.
Okay. No, just to, no. Plunge pool one profiles. If I show them, they will understand, right? Why we need plunge pool. I put there or no? I don't understand. Wait, I will check from my slides. Okay, then I will tell you. Okay, you can show this also apartment. Okay, yeah, go further, please. End anything there? Mm. I just want to show plunge pool profiles. That's all for Parvati Dam Spillway, which I conducted. It is there or no? So this one rock mass rating curve. Okay, next rock mass rating. Oh, nothing there. After that, nothing there.
Nothing there, sir.
Okay, no, no,
There's
nothing.
the
That
start
one, nothing.
slide
But
on
plunge
which
pool means, yeah, yeah, yeah. Last slides. Okay, after conclusion. No, no, yes, 139. Wait, I will tell you. So this is what I done. GP. Okay, Prashant done. Okay. Then this one network will not go that much. Okay. Okay, never mind. Nothing. That one, like trapezoidal channel type on plunge pool. Then where location coming? That's what due to water surface profiles. Yeah, yeah, it is there, Rohit. Rohit, it should be there. After thank you, please go next slide, please.
okay, sir, I'll do.
It is there. It is there. I am also checking in on my mobile. That's why how can if I show that one then I'm very happy. Okay, go to end please. After thank you, just two slides for Bati Dam Spillway. One is gated operation. Slowly go. No. Yeah, no. Before thank you. After this, somewhere I saw. Go. I will tell you slide number. Yes, please go up. Little bit up. After this, my conclusion, right? Pleasant conclusion. 121. Go. Yeah, no, not this one. This one. Okay, next. Yeah, before this, I saw my slide now 92, around 91, 92. Go for yes, 91. Yes, after thank you. See, that's what. Yeah, I did not forget. Here, see, gated means you can also know you all like you all aware, right? RFS how it will work. So if you fully open, what will happen? What will happen, Rohit? If you fully open gate, fully open, your thickness of that means that very big, right? So due to momentum, due to heavy, it will go. If you make it very less, means like gated operation, you can observe here. This is your see here water surface where it is plunging. See how many meters means it converted to proto. See here 65, say 66, something 70. So lip from here to here. See we are hitting. Okay, so this trapezoidal shape you can see. So you can propose plunge pool like this. Okay, correct. Now you got idea, right? Why we need plunge pool? Agree? Hello?
Yes, yes,
Agree,
sir.
right? Next,
Yes,
next, see, otherwise no meaning, right? That's why we will do model studies. It will give clear picture, at least pattern. It will give very clear. Jet also only this Kawakam is a due to air resistance in nature, correct? So model study there is not that much wind, right? Kadakmasla. Okay, here you can see due to ungated means I did not know. So this much discharge. See, I can see here now. 1850 maximum the original river bed where is it hitting 160 meter, right? With chainage. Okay, so that's what so this one you can preformed pool plunge pool. But another thing we what to do expensive only, but for safety also important, right? Why we all take expensive safety. Okay, here also same plunge pool proposed from model studies. Okay, now okay, one by one, which one is better means ANFIS is much better. Okay, one by one questions we will go. That one you can show that paper, please. I will wait. That paper just now I shared. That one, I have many, but no time right here. 2 o'clock already. Okay. Okay, this one thing I did single author. If you work in, I was after my PhD, I went to Taiwan, and then after I went to University of Science Malaysia. I did not go America since my name Mohammad, so correct, very difficult. Okay, this one what I done here gene expression programming to predict score at bridges. Okay, uh, abutment. Okay, next please. I have used some Subhash the Professor Subhash the Kharagpur is the data, and also some other researchers one. Okay, normally if you use other data, they will angry. Okay, correct. But I put on my paper, so I get more citations. Okay, Mm, all data. I personally worked, but what to do. Okay, so here same you can see depth of score is a function of same velocity. You can see a little bit plus, please, plus, zoom, zoom, and equation one show them. Here very fortunate. This Mujambil from Aligarh University, maybe he done from Kharagpur. So this one day Professor Desar and Barbia data. This the equation. See everywhere D50. So the score same. Score is nothing but due to either horizontal jet or vertical jet. Sometimes natural also. Okay. So but you need to calculate equilibrium score. That means there is no further score. Okay. So here. So same depth of score is function of velocity, the abutment length, then approach flow velocity, critical velocity, then bed material. Little bit if you go beyond river mechanics, incipient motions, how shear stress, this one is tractive for that this it will come. Okay. Okay, next please. Little bit go down. So again, some after depth of score is function. See, then again, same see Buckingham Python. See here, depth of score relative to L. Okay, then fraud number, then everything depends on L. Okay, then case is factor. Okay, one of the factor, shape factor. Here see same thing. My papers only and face and all. You do recently here we can read. Then someone asked right which one is good, why good. Okay, have been recently shown the effective score on hydraulic structures. Okay, even sediment. Okay, in environment engineering, I'm very much afraid. Especially wastewater engineering. Even during my study, also I did not study much. That time, my undergrad also, I don't like that subject. Wastewater engineering. Okay, though I am working here. Environmental. I never work in that one. Hydrology, some papers. Okay, so here you can see fraud number. Okay, then also you can see yes, relative density. I mean, see this one here. What I'm trying to say, density fraud number maybe. Okay, next go. Yes, this one density fraud number. Okay, next go. Then go. This one your how flow will come. Abutments you all aware, right? I don't need to explain how bridge abutment. Okay, so how flow attacking if vertical wall, 45 degrees wall, semicircular. Okay, next please. Next slowly little bit go. So here what I did, I thought given many papers worked, but I am single author here. Okay, next please. Some gene expression programming. It's coming from where? Genetic programming means even genetic algorithm means search based algorithm means best one. So this is the flow here. See, abutment how it's cakes, then sand bed, width, then okay, then approach what's flow depth, then DSE means equilibrium score depth. Okay, next please. So some literature about GEP. Nothing but suppose I want to give to Rohit 100 rupees. Then I will take the Awari sir 80. Then your madam 20. Then I will make perfect. It means plus minus. This will what I try to understand. For you can go a little bit go down, please. I will show you. So plus minus only here also don't use many functions. Otherwise, you can go please a little bit go. I will show equation. So yes, this is the same simple neuron. I will compare with the neural network. Next equation. Yeah, see here. See, please see here. See plus minus here right hand side. Okay, just hold on. Rohit. Here see plus minus. Then multiplication division. Here right hand side. Yeah. Here I will show you. Yes. See that one. Only simple. Only that one is. At least you can use root. But don't use many others. Then people means your means wherever design office people never like if you give. Correct. Even your friends also not appreciate. So much Rohit presented this much equation. It's very complicated. Correct. Even okay. A little bit go down, please. So I used this one. So just it's make adjustment only. Here also see 235 8 data sets 75% I used. Then testing 79. Yeah, this is my equation number 5. You can see, even though many people they will say this much how to work. Correct. If I give to my students in a final year exam or in a big in within 3 hours they will angry. Afterwards, if you ask, they will say no. No, not a good exam. This fellows make complicated. Oh, yeah, that this they will tell. Okay. Another equation, peer score I published. Finally, in typing mistake, then so many comments came. Means personal comments. Okay. The equation number 5. Okay. So this is nothing but the trees. See, you can see here how you will write. If you want to write, see square means C1 means that 4.34. Okay, set one trees. How it will work. A plus B. How you will write. Same. Okay. One of my other student working. This one. Even Prashant also worked with the stage discharge curve. Okay. Okay. A little bit go down, please. So here, after working, so we should not be black box or simply anything coming. Then we should throw on, this technical society. Very difficult. Here also, see the error measures. Here, see, I did not use correlation coefficient. Now onwards, I used question term determination. Since if any American reviewer, they will say, okay, they will say no, no correlation coefficient. You can use. Show me this one. Okay, that is the thing. Okay. So here mean absolute deviation, same error measures are used. Is the range of data. See range of data, table one. Okay. Then here you can see also table two. Only this much my plus minus and star. Then division symbol square root. I used it. That's all. Okay. Some nutrition, some terminology there. Same thing like same biologically that they say. Okay. Transposition. Some definitions. Okay. So this is the. Okay, I think. Okay, any questions they have? I think five in chat room. Five questions. Okay. Yeah, here also same thing I done sensitivity analysis. Rohit. That's all. Nothing same. You can literally you can see in chat room. You can show me some five comments there. Comments are what they're asking.
So would you like me to read out the questions to you?
Yeah. Okay.
Okay.
Can if you show also no problem. Yeah, you can read better, right? You can read better.
Okay.
Thank
First
you.
of all, thank you very much,
Yeah.
sir, for such a fruitful and knowledgeable session.
Thank you. I'm very happy if you understand. But initially, even when I study, also that time, first I don't understand anything. To be frankly with you, then slowly, how the way your teacher will explain to you. Okay, my time Londe sir helped me that time. Pune, who is working in professor in VIT, I think. Okay, yes, please.
Okay,
Questions.
so this question is from
Someone
True.
asked. Yes. No deflector. Someone asked, right? Deflector.
Yes.
Nice.
Yes. Trupti is asking
Mm.
that is it possible to use a deflector to reduce a score in plunge pool? Or is there any
No,
example where
no, that one, what happened? See, whenever nature, see, that's what we are playing with nature. What happened in Dolinga case? So, jet going and hitting to right bank, correct? Since someone hitting, but your name Siddharth, Rohan is hitting, but even I am also hitting, means one should only one avoid, right? Score is natural, like human. Death is the same way. We cannot avoid score. Only possible two alternatives, right? One is plunge pool you can make, another one just a tile water level, right? That's all. Reflector, their idea, that one. So ultimately what happened, you can see, if you see slides, three spans, then again, I left in 2006, 2005, then again they made it two only. So what happened now? What is happening in Doliganga, you tell me? Correct. Upstream, not only downstream, upstream also big problem. That time only my boss told. But what that time, one of the director, what he told, when nature is going to do, why should I waste my money? He Sometimes you have to face very arrogant people in life. Okay. So my boss was very knowledgeable, Katsurya Sahib. You can refer textbook. He told, but he silence, what you can say, higher authority. Okay. That time one of the director, I don't want to use the name, I still remember. So he used that words. So what happened here? So you can avoid, yeah, the spray like something. Okay, it's absolutely reducing, but still it will be there. It will be there. Okay, it will be there. Score will takes place only, no doubt about that one. Even stilling basin, if it's a stilling basin, means you are forming hydrologism to means dissipate energy, you can say, means kill energy. Okay, so still it score will takes place, that one. No doubt, guarantee it will takes, even though even Louis get many, you can see score papers, even though see many bridges failure. Okay, even though we try to deflect water, right? So that's what you are using, like transition in okay, in bridges, right? We will put round nose, rectangle nose, but score takes place there also. So we can't avoid, but it can reduce, surely reduce. Okay, next question, please.
The next question is from Dattatre. Which
Mm.
one is better for prediction, ANN or ANFIS?
Anfis, we showed, right? We proved that one. It give highest prediction, but so many membership functions there. So people both Anfis and this one, no one will. The final one I show you just now, simple like equation, right? Regression equation. You will appreciate that one. Just now I show last paper. So gene expression programming is much better, much advanced, and present at least 8 10 years. That also become old only. Okay, gene expression programming, good.
The next
Okay.
question is from Gagandeep. What is the
Okay.
percentage error between the findings of ANN and the physical model?
That's what physical model means. You are giving only regression equation. Correct. Regression equation. We proved, right, 0.84. But here 0.99 we reached, right? We proved that also. Why we went to ANN? Physical modeling are giving only like a regression only. Correct. Regression. But again, you are using this what good question. This one what we are using observed data, whatever you are conducting, right? It's, many people want to, you cannot mathematical output to again. Correct. Again, we cannot input to neural networks. We are using observed, that's why observed and predicted, observed and predicted. Okay, that's prediction. Okay.
So I think that's all with the questions.
Okay.
So I would like to thank you, sir, for answering the questions. We students are
Thank
grateful that we got an opportunity to interact with you.
Thank you. If any doubts, please feel free to email me. I know I go a little bit far. I worked many places, but no one understand. First thing, since at least hope you understand. Okay, my language also changed when I worked in China, Malaysia, the Fiji Island, then Saudi Arabia. This one my fifth university here. After I left the country 15 years ago. Okay. Thank you so much and good night. Sorry, good day for you. Okay. Okay.
Hello,
Thank you.
Nangre sir is there. Nangre
And
sir.
also, I should say to Awari sir and Usha madam, okay, Mega madam, sorry, to invite me for this session. Thank you for inviting me.
Thank you,
And
sir, for accepting our invitation. Your session was very informative and knowledgeable. Thank you very much.
thank you, man. Thank you. You are welcome, man.
Sir, one of our faculty member is eager to ask you some questions. Can you please answer his
Yeah.
queries?
Yes, please. Yes, please. Yes, please.
नांगरे सर तुमचा आवाज कमी आहे आवाज येत नाहीये बरोबर
Hello. Hello.
Yes, sir. Yes, sir. Yes, sir.
I'm audible.
Yes, sir. Yes, sir. Yes, yes, please.
Yes, sir,
Yes,
you are
please. Go
audible.
ahead. Yes, sir.
So Ajit sir, you are nicely presenting and you are presenting both the models very nicely. And you
Thank you,
compared
sir.
the results about the scoring action in stilling basin.
Okay.
So it's
Okay.
my one question to you. For minimizing the scoring action, what would be the leap angle for the deflector?
Yeah, that's what we told, right? Very good question. Means just now I repeatedly told, if we studied all in intermediate, I think we can say +2, x equal to the range, horizontal range I'm talking about, x square sine 2 x equal to u square sine 2 theta by g. We all aware this one. Okay, one of the another paper. So what will happen? Just go very further. Okay, further then. It will impact, right, wherever impact. So due to air resistance, it will, the energy almost that's what Kawakami proved 85% energy lost. So mostly 45 degrees, I can say 45 degrees, sir. So that's what we
My,
observed
my,
here in
my
Srisalam
question is
Dam.
here. I am talking you about the field only,
Lip angle.
not
Mm,
with the model. So
mm,
for minimizing the scoring and erosion
mm,
action in stilling basin,
mm,
what
mm.
would be the optimum tip angle you are providing?
No, stilling basin. No, no, stilling basin. No lip angle, sir. Stilling basin. We will use. We will form hydraulic jump. Here, 45 degrees. I told right. Many dams. That's what they made mistake in Srisalam Dam in practical. In
No, sir.
reality
I am
prototype.
talking
Mm,
you. Stilling basin is one of the option. Another
mm,
option, you are providing the buckets.
okay.
If you have
Okay.
taken the jump from the bucket towards the stilling basin, so what would be the ideal condition? Whereas the no scoring and no erosion action in stilling basin.
No, I never study such a work. Stilling basins I never worked. To be frank with you. Okay.
Okay. Another question is there.
Mm,
So
mm,
what
mm,
would be the ideal condition for the hydraulic jump and the
mm,
tailwater depth so that no
mm.
scoring and no erosion action should be there?
That's what scoring anything. So any dam score takes place only. That one guarantee. That 100% guarantee. Why we go for whenever tile water depth available, whenever your geology rock. That's what still studies rock mass rating. This studies still further studies need. This will happen only. Many dams you can see without scoring nothing there, sir. So far, for my knowledge,
Another
score
thing
takes
is
place
that
only.
being as an
Mm,
engineer, being as a hydraulic engineer, we are
mm.
trying to achieve it now here. So
Mm.
what would be the ratio of the sequence depth ratio you have to be
No,
maintaining?
that one, no, that one you were talking about hydraulic jump. I did not. That one
Yes, I am
hinges are,
talking about hydraulic jump.
no, no, I did not work that one. Maybe you can ask hinges are done that one. I was examiner. I forgot for him.
Same
Hinge,
work
Professor
I
Hinge,
have carried.
Then I think,
Same work I had carried it. Hinges sir has carried with the hydraulic jump. I am also doing the
mm.
same work with the hydraulic jump as well as I am
I
doing
don't know
with
that one.
the of
That's one.
roller bucket.
Mm, roller bucket and all. I know
And
that one.
you are nicely
Mm,
presented about the plunge pull
mm.
concept.
That one I did not work. See, I worked, I had structure all ski jump bucket only. My PhD also I jump bucket. After that, my student worked, this one pipeline score. Ski, when I come across this one, hinges or lecture I saw when I was examiner for him. That time I saw. Then recently I was explaining to my students, but so much research came. You are right. That one sequence depth one and many energy dissipation. That much percentage, this much percentage. Nothing that one means
And
I did not go through. I did not go through.
there was
Yes.
one hydraulic model prepared by CWPRS on Bhutan
Mm,
Spillway, which is now
mm,
located in Madhya Pradesh. And they have to be
I really don't know, sir.
60%,
Okay, sir. I'm really sorry. I cannot speak
they
much.
have to be
Here
achieve
night
60% of
220
energy.
here. No, no, no. 220 later. Whenever you feel free to call me, then here
Yes.
220. I cannot speak loudly. Also.
And my
Okay.
last question to you.
Mm,
So for getting this knowledge by applying the knowledge of the ANN, so what would be
mm,
the reality you have seen it as compared to the
mm.
physical model?
No, that's what I told first. Only physical modeling is physical modeling. That's one accurate. This one only it will get only some idea you will get, but neural networks till now what I told you, no designers, no one will know. Practice engineers will appreciate. Again, even see still CWPR there. You need physical modeling. They will trust. That's what I told exactly. At least it will give pattern. It will give here, it will this much length. That's why I showed plunge pool, right? That will happen means it will happen there also, but some with a little consideration. As I told, in reality, some air resistance. That's one. So model studies is model studies. Even if you compare to CFD also, CFD many Navier-Stokes equations, no use. Physical model is ultimate alternative tool and good tool only. This one.
Have you studied any correlation in between the percent of dissipation with
No,
this
no, 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 no.
sequence
I
of
know,
ratio?
what you were talking. I never done that one. E1, E2.
Okay.
Okay, sir. Good night. Thank you very much.
Thank
You
you.
are
Thank
talking
you.
only
Nice
energy
to meet you.
dissipation. I
Nice
did
to
not
meet you.
work that one. Okay, bye, sir. Thank you very much.
Okay, bye.
Okay, thank you,
Thank you,
madam.
sir. Thank you,
Siddharth,
sir.
Thank you very much. Is talking energy dissipation one which okay. Thank you very much, madam. Good night.
Siddharth, please
Thank
proceed
you.
with the vote of thanks.
Okay,
Yes.
thank
So
you.
now we are
Yeah.
close to the end of this erudite session, which we thoroughly enjoyed. Now I would like to propose a vote of thanks. I, Siddharth, on behalf of Department of Civil Engineering, AISSMS College of Engineering, Pune, would like to thank our Honorary Secretary, Sri Maloji Raja Chhatrapati, the Governing Council, and the Managing Committee members of AISSMS Society Pune for providing us with the platform to conduct such events and motivating us. I extend my gratitude to our guest speaker, Professor Hazi Azamathulla, sir. We are grateful for the excellent coverage of all the topics which you mentioned that are crucial for our future. We are all inspired by your gracious word. I would like to thank our principal, Dr. D.S. Bormane, sir, for his constant encouragement, our head of department, Dr. Uttam Awari, sir, for his immense support, and our faculty coordinators. Professor M.S. Chiwande, ma'am, for organizing this session and giving us the opportunity for this fruitful interaction with our guest. A big thanks to our organizing team for all the behind the scenes work. Last but not the least, I would like to thank all the live audience members for being a part of this session and making it more interactive. Now, with the permission of all the dignitaries, I declare the event is over. Thank you.
Thank you very much. Good
I
night.
request all the students and the guests to please keep their cameras on. And Rohit, we can have a picture.
Sure.
Thank you, Rohit.
Rohit, are we done?
Thank you.
Yeah, we are
Thank you,
done.
Rohit,
Thank you,
and
everyone. Thank you, sir.
thank you, Rohit and Siddharth. I'm very thankful, and Mega Madam. Thank you very much. Good night. Thank you.
Thank you, sir. Good
Thank
night.
you. Thank you, Awari, sir. Thank you, Awari, sir.
Thank you, sir.
I request all the students to please fill the feedback form and you'll be receiving the certificates. Thank you.
Recording stopped.
The feedback link will also be circulated in your class groups.